everyone, myself Prateek Mishra and I welcome you all to the YouTube platform of IMS GATE Academy. My dear students, GATE 24 is over, results are out and the counseling is going on. I hope you might have registered for COAP portal and you have also filled form for different IITs for choosing the different specializations. Again, I am going to repeat this. All the counseling rounds will be conducted by COAP for IITs and IISc. Separately, there will be CCMT counseling for NITs that will going to start later on. Now for GATE 25 students, if you have made your mind to prepare for GATE 25, first of all, my dear student, is start preparing your basics. Basics are the very important thing in your entire GATE journey. This year and since last 4-5 years, we are observing that the questions which are framed are more oriented towards the basics. Even the highly conceptual question require the use of very basic concept of that particular topic or of that particular subject, right? So I am here again myself Prateek Mishra and I am here to discuss the foundation courses or the foundation of environmental engineering. Environmental engineering is one of the highly weighted subject for civil engineering students. It has a weightage of 10 to 15 marks in your GATE exam. This year we have seen very good quality questions from environmental engineering and based on those questions we have designed this entire foundation course. This foundation course will really help you to grasp the advanced level concepts of environmental engineering. So in this coursework of foundation series for environment, I will personally going to discuss all the basics which will help you to read the highly conceptual concepts. Okay. So before starting with this foundation course, let me give you some announcements. First of all, my dear students, the Telegram group link is given in the description box. You can join our Telegram group to get the daily quizzes, to get the job notification update regarding any PSU or any counseling session is updated in that Telegram group. Again, the link is given in the description box. We at IMS GATE Academy, we offer you 4 different types of program. Online program, offline program, hybrid program and the self-learning program where we provide 800 hours of live teaching with interaction. We provide you with the theory and exercise book and especially in our exercise book, there are more than 4,000 practice questions which are well placed in level 1, level 2 and level 3 so that even the student has an idea in which level his or her preparation is. We provide you with the GATE question bank. Again, I will going to repeat this. It is the premium product that we have. It contains GATE question of last 34 years. Since the time GATE started, we have segregated all the question into different subjects and even for every subject, the questions are placed in different chapters, even for different sections. It is one of the best practice material that actually helps you to practice the GATE concepts. We provided detailed solution, alternate solution, video solution. We have also provided with the key points and the chapter overview which helps you to just use that concept very easily, which also improves your concept application ability. We provide with 12 personalized one-to-one mentoring sessions. IMS GATE Academy is the only GATE institute in the country to provide personalized guidance to our students. We personally believe that if a student is well oriented, well planned, then eventually he or she will going to have the best of the results. We provide you with the test series which contains more than 130 plus tests and I proudly say that it is India's largest test series provided by any institute. It includes chapter test, subject test, multiple subject test, advanced subject test. Then you have full length mock test with the video solutions. So these are our course features that we provide at IMS GATE Academy. If you want to speak to our counselor, you can just take down this number and you can speak to Rahman sir or Chaitra ma'am and you can talk about the different courses. Even if you feel like speaking to mentors, again you can contact this number. Okay. So these are some of the, I should say, news that I have to tell you. But let's begin with this very beautiful course of Foundation of Environmental Engineering. My dear students, usually we read this subject in the examination just to pass. Even in the semesters when this subject is taught, it is taught in such a way that nobody has that much interest. But it is one of the key scoring area in GATE examination. And believe me, the questions of environmental engineering are so easy, but still student do not understand the question because he or she has not read the concept well. From this foundation series, my first aim would be to give you that perspective of environmental engineering which actually helps you to connect it with the practical life. And once you start connecting your civil engineering subjects with the practical life, it becomes very easy to understand the subject. It becomes very easy to remember the subject. It becomes very easy to apply the concept of that subject to solve the question. Okay. My dear students, environmental engineering comprises of water supply engineering, wastewater engineering, air pollution and solid waste management. These are the four legs of environmental engineering. If I talk about the weightage of these four segments, so usually you see a very good quality question framed from wastewater engineering and also from some of the topics of water supply engineering. But I tell you the scoring area. Solid waste management and air pollution, this much syllabus is there. And we have seen equal weightage given to these two topics as well. Means out of these four topics, you will find that all the topics are equally weighted some or the other way. And from recent 4-5 years, we are seeing good quality questions that are framed from solid waste management, right? Now, first of all, my dear students, why would anybody read environmental engineering? I'll start with that. Why you should read environmental engineering? So, you being a civil engineer, you are responsible for transporting water to the community. The first part of collecting the water and transporting it to the community is termed as water supply engineering or raw water engineering. So it is very simple. You collect water from the source, you treat it and you supply it to the community. This engineering is termed as raw water engineering. So you understand this. You have a source. This source of water can be either river, lake, pond, ocean, seas, anything. So from any source, you will going to collect the water, you will going to analyze the water and then you will going to provide treatment to the water and you supply this water to the community. This part of engineering is known as raw water engineering or water supply engineering. This is known as water supply engineering. Very simple to understand. Water supply engineering. So what is water supply engineering? Water supply engineering is simple. Collecting water from the source, treating it and supplying it to the community. Now second, once this water is supplied into the community, now this water is converted into wastewater. Now again collecting this wastewater, treating this wastewater and disposing this wastewater again back to the source. This is classified as wastewater engineering. This is wastewater engineering. So when you start relating the subject, right, it becomes very easy to understand the subject. So again, collecting water from the source and supplying it to the community is water supply engineering. And then collecting the wastewater from the community, treating it and disposing it back to the source is termed as wastewater engineering. Now, my dear students, these are such practically related situations that each and every day we drink water and then we also produce some wastewater. Then comes the next topic of discussion, that is air pollution. So usually so many pollutants are there and we see them on daily basis. We usually see the smoke coming out of the chimneys from our households. We see the smoke coming out of the vehicle. We see the smoke coming out of the industry. And where this smoke is going? This smoke is there in the atmosphere near you. So analyzing that atmosphere which contains pollutants and then accordingly treating that atmosphere in order to reduce the pollutant is classified as air pollution or air pollution engineering. Last one is your solid waste management. Again, so much of solid waste we produce on daily basis. We produce garbage, we produce rubbish, then we produce ash by burning something. So all this solid waste, again collecting this solid waste and treating them so that we can utilize the best way, and it should be an economical treatment process, and then disposing it is classified as solid waste management. So all these are literally the very, very important part of the community. If any of this part is lagging in the community, then that community starts feeling so much of trouble. Like my dear students, right now you might be hearing about this situation. In Bangalore, there is a huge water scarcity. And again, this water scarcity happened because of the not proper management of water. Okay. So all these are very serious situations. And one or the other way, each one of us are involved in all of these situations. So why not understand this situation properly so that at least we can come out of an idea which can actually help the community to retain the water, to use it in the optimum way, and you should produce the minimum of the wastewater. Okay, so I'll start one by one. So we have first topic of discussion, that is water supply engineering. My dear student, water supply engineering is related with the drinking water that you have. The water that you use for drinking purpose is the end product of the entire water supply engineering. Means when you open the tap and that drinking water comes out, that is the end product of water supply engineering. So my dear students, water supply engineering starts by analyzing the demand of water. Means how much water of required in the community. So the first topic of discussion is water demand. In the water demand, we actually find out how much quantity of water is required by the community for different usages. Now, in order to find out this water demand, we should know the population of the community. Then only we can find out how much water is required. So the second topic of discussion is population forecasting. In this population forecasting, we actually know what is the existing population and how the population will grow in next 2 or 3 decades or 5 decades, so that we can actually calculate the amount of population that will be present after 5 decades, and accordingly we can predict how much amount of water will be required in next 5 decades. Okay. So population forecasting is the second chapter in water supply engineering. So first is calculating the total quantity of water required in the community, that is the water demand. Now for calculating this water demand, you need to know about the population of the community. So second topic of discussion comes out as population forecasting. Once you have calculated the amount of water required in the community, the next step is you need to find out what are the different sources from where we can collect this water. And these sources can be rivers, lakes, ponds, seas, oceans, etc. So the third topic of discussion is the sources of water. Once you have collected water from any source, once you have extracted water from any source, you cannot consume it. First, you need to check its quality, right? You cannot just pour a glass of water from the river and start drinking. Okay, one or the other way it is different, but regularly you cannot consume that water, right? Especially in the rainy season. You cannot just pick a glass of water from the river in the rainy season and start drinking. You may get ill, you may fall ill, right? So once you have collected this water from the source, you need to analyze the quality of water. The quality of water is analyzed using water quality parameters that we will going to see later on. But there are basically 3 water quality parameters: physical, chemical and biological water quality parameter. So after collecting water from the source, you need to check the quality of water. Based on the quality of water, the next step is you treat the water. So next topic of discussion will be treatment of water. Once this water is treated, now this water is supplied in the community by the means of different water distribution systems, right? This water distribution system includes, so from this treatment plant, we fetch the water and we store it in the service reservoir. You might have seen these overhead tanks which are there. So water is stored in these overhead tanks, and from these overhead tanks, the water is distributed in the community by the use of various water distribution system. So from the overhead tanks, that is the service reservoir, and the water distribution system, this entire thing is the water distribution system. So this is your water supply engineering. Starts by calculating the quantity of water required in the community. For calculating this quantity, you need to know the population. So next topic is population forecasting. Once you know the total quantity, you need to identify different sources from where you can collect this water. Once you have collected this water, you need to analyze the quality of water, and now based on the quality of water, it is treated accordingly. So next topic of discussion is treatment of water. Once this water is treated, it is supplied in the community using the water distribution system. Okay. Out of all these 6 topics, my dear students, the area from where regular questions are asked is this quality of water, this one, quality of water, and the treatment of raw water. There are certain fixed areas from where regularly we are seeing the question. So especially this quality and treatment of water can be identified as an important part in your water supply engineering. Now, when we talk about the sources of water, this sources of water is a kind of a common topic, right? Some part of the sources of water you will also study in geotechnical engineering and hydrology engineering, right? Chalo, moving on with this, let's start with this first topic of water demand. So, my dear student, first of all, what do you understand by raw water? Can anybody tell me in the comment? What do you understand by raw water? Water supply engineering is also termed as raw water engineering. So, what do you understand by raw water? Okay. So, if you collect water directly from the river, okay, you can see this muddy river which is flowing properly, right? It's a beautiful view. Then you can see this lake, right? If you are fetching water directly from the lake or the river or any sea or ocean over which no treatment is provided, no artificial treatment is provided. So, if you are collecting water from any source over which no artificial treatment is provided, that water is termed as raw water. So, if you are directly collecting water from any river, any lake, any sea, any ocean, that water will be classified as raw water. Okay. Now, usually here one question comes in the examination, not in GATE, but for SSC, JEE, state PSC examination, and that question is whether underground water is raw water or not. Again, I'll repeat my question, whether underground water is raw water or not. We have seen one definition. What do you mean by raw water? Raw water is that water over which no artificial treatment is subjected. No artificial treatment is subjected. No artificial treatment is subjected. So, raw water is basically that water over which no artificial treatment is subjected, right? Now, you see this. So, I have told you that raw water is basically that water which is not subjected to any artificial treatment. Means, if you are directly extracting water from the source, that is termed as the raw water. Now, when you observe the groundwater, you see this. This is my ground level and this is the rainfall that is taking place, right? This is the rainfall that is taking place. After rainfall, whatever water which is collected on the surface of the ground, it starts percolating through the soil. It starts infiltrating through the soil like this. It starts infiltrating through the soil like this, right? It starts infiltrating through the soil like this. Whatever water is collected on the surface of the ground, it starts infiltrating through the soil like this. Now, when this water is undergoing infiltration, this water is also undergoing the process of natural filtration. This is also undergoing the process of natural filtration. It is also undergoing the process of natural filtration, right? Now, how this filtration is happening? This filtration is happening because of the soil medium which is present below the ground level. When the water is passing through the soil, that water is undergoing the process of natural filtration. And then finally, it is collected at this groundwater table. Then finally, this water is collected at the groundwater table. Now, tell me whether this water is raw water or not. If you are fetching this water, underground water, then this water will be raw water or not. Can anybody tell me whether this water will be raw water or not? I have told you the entire mechanism. Rainfall is getting right on the surface of the ground, then this water is infiltrating through the soil medium, and while this water is infiltrating through the soil medium, it is also undergoing the process of natural filtration, and finally it is collected at the groundwater table. Now, if you fetch this groundwater, then this groundwater will be classified as raw water or not? So I will say yes, it is classified as raw water, because this is undergoing natural filtration, right? Any man-made or artificial treatment is not given. All the treatment that is happening right now is natural. That's why this underground water will be classified as raw water. So this is your underground water. This is your underground water. And this is also classified as raw water. This is also classified as raw water, right? So this water is infiltrating like this through the soil medium, and while this water is infiltrating through the soil medium, it is undergoing the process of natural filtration. And due to this natural filtration, after this natural filtration, this water is getting collected at the groundwater table. That's why this groundwater is not subjected to any artificial treatment right now. That's why it is classified as your raw water. Okay, so no doubt in this. Chalo, moving on with this. Now next is, in order to design the water supply scheme, now this design will happen corresponding to the water requirement or the water demand of the community. Accordingly, we will going to design the water supply scheme, right? What do you mean by designing the water supply scheme? So designing water supply scheme means how much amount of water you need to treat every day so that it satisfies the need of the community. Okay, what I am saying again, what do you mean by designing the water supply scheme? Designing the water supply scheme means how much quantity of water you need to treat every day that satisfy the demand of the community. That is known as designing the water supply scheme. Now, in order to design the water supply scheme, you need to first calculate three entities. The first thing that you need to calculate is known as annual draft or annual demand. Now, what is annual draft or annual demand? It is the total quantity of water required in a community in 1 year. Annual means an year. Annual draft or annual demand means the total quantity of water required in the community in 1 year. So, for designing the water supply scheme or raw water scheme, following entities should be calculated. The first entity is known as annual demand or annual draft. It is the total quantity of water required in a community in 1 year. It is the total quantity of water required in a community in 1 year, and it is calculated in terms of volume, right? This V is the volume of water required. This V is the volume of water required in the community in 1 year. So first you calculated the annual draft or annual demand. Second is annual average daily draft or annual average daily demand. Annual average, you see this, annual average. Annual average means you take the average of the total water required in 1 year. So you simply divide this V by 365. So you will get the annual average daily draft or annual average daily demand. Again, it will come out in terms of volume. So the second quantity required is annual average daily draft or annual average daily demand, right? The third is annual average per capita daily draft or demand. Now you just understand the term, and that will help you to determine the formula. Okay, you just remember what is annual draft. Annual draft is the total quantity of water required in the community in 1 year, and that is equal to V. Okay. Second is annual average daily draft or annual average daily demand. That is the total quantity of water required in the community in 1 day. Simple. Third is annual average per capita daily draft or demand. It is the total quantity of water required in a community by one person in 1 day. So if I am saying this in your mind, I think you are already framed the formula. That is V divided by P, that is the population of the community, multiplied by 365. So V by P into 365 is the annual average per capita daily draft or daily demand. Okay. So first, for designing the raw water scheme, you need to identify these three things. then only you can supply, then only you can design the raw water scheme. So first one is annual draft. It is the total quantity of water required in a community in 1 year. Second is annual average daily demand. That is the total quantity of water required in a community in 1 day. Third one is annual average per capita daily draft or daily demand. That is the total quantity of water required by one person in 1 day is termed as annual average per capita daily draft or daily demand, right? So these three are the formulas. All these quantities are calculated in volume. So I'll write this. All these quantities are calculated in volume. All these quantities are calculated in terms of volume. All these quantities are calculated in terms of volume, right? Chalo, moving on with this. Next is, now my dear student, this total water demand. What is water demand? Water demand is the amount of water required in the community. Now where this water is required, this water is required for different purposes like cooking, washing, bathing, industrial purposes. Then you have water required for different schools and colleges. Then you have water required for firefighting. Then some water is lost in the distribution system. Okay, so the total demand of water, we have categorized it based on the usage of water. So based on the water usage, the total water demand is classified into following types. Based on the usage of water, the total demand of water is classified into following types. First one is the domestic demand. Domestic demand, as you can see here, it is the amount of water required to satisfy the domestic needs. Again, cooking, you require some water. You bathe daily, right? Again require some water. For washing hands and washing your vegetables, again you require some water. Whenever you use the washroom, again you require some water. If you want to clean the floor of your house, again you require some water. If you clean the lawn, if you want to garden, right? If you want to water your garden, water your plants, again that water is required. So all the water which is required at your household is termed as the domestic demand. So the first demand of water is the domestic demand. It is the amount of water required for the domestic usages. There can be different domestic usages like washing, cooking, bathing, etc. Okay. You can list down all the domestic usages. I have just given you some of the pictures, right? You can see a beautiful child bathing like anything, right? Then you can see a person just cleaning his hand with a tap. So all these are the examples of domestic demand. So the first type of water demand is the domestic demand based on the type of usages. Second one is the industrial demand. Now my dear students, the total quantity of water that we supply into the industry of a particular city, that is termed as the industrial demand. Now you may think, sir, ki in industry, the water will be used for different processes, right? You are thinking in the correct direction. I am talking about only that water. The water which is used by the industry for different purposes, that is termed as the industrial demand. Like you see, for paper, right? Usually huge amount of water is required. If any question comes that which industry utilizes the maximum water, then you can answer it confidently that paper industry utilizes the maximum water. Then you see this jaggery industry, right? Jaggery industry again utilizes water. Then you see these power plants. Huge amount of water is required in power plants. Now you will say, sir, where this water is required in power plants? So my dear, you have one unit known as boiler, in which the water is converted into steam. So there you utilize huge amount of water on daily basis. So all that water which is used by the industry of the community comprises the industrial demand. It is the amount of water required to satisfy the industrial needs of the community, that is industrial demand. Again, I have attached some picture which is showing some pipes, and these pipes are taking the water to a particular process. Okay. The next type of water demand based on the type of usage is the institutional demand. Now, schools and colleges are not the only institutes of the community. When I talk about institutes of the community, it includes government buildings, government offices, hospitals, then you have schools, colleges. All these are the different institutes of the community. So the water required by the different institutes of the community is termed as the institutional demand. Okay. So you have schools, colleges, then you have hospitals, then you have government buildings, then you have, if any monumental structure is there, again it's an institute of the community. So all that consists of institutional demand. So next type of water demand based on the usage is water for public use. Now the water used in the community for cleaning the roads, for gardening the public gardens or watering the public gardens, that water is termed as water for public use. So water for public use is that water which is used for road cleaning purposes and which is used for watering the public gardens. You can see here, I have also attached some picture. There is one truck which is cleaning the road. You will see this sprinkler which are attached in the front bumper of it. Then you can see this, a person which is gardening the public garden, watering the public garden, right? So these are the 4 different types of water demand based on the usages. Next type of water demand based on the usage is the fire demand. If any fire outbreak happens in the community, the amount of water required for the firefighting is termed as fire demand. Okay, this is, I think, very simple to understand. Then you have this thefts and losses. So usually in our country, this is a sad truth, but it happens in our country. Although it has reduced drastically because all these pipelines are now underground. Earlier, in some of the cities, these pipelines that are laid used to be on the surface. But since now most of the pipelines are underground and most of the areas are even metered, water meter is there. Okay, so all the theft had reduced drastically. But still, in some areas, we see the losses due to any leakages. Okay, so the water loss due to leakages in the distribution system comes under thefts and losses. Or if any water is illegally used by the illegal connection, that again comes under thefts and losses. Okay, so we need to also consider this while calculating the total water demand of the community, so that we can get the exact calculation that how much exact amount of water is required. So the last type of demand is thefts and losses. It is the amount of water lost due to leakages and illegal connections in the distribution system. So these are the 6 different types of water demand that we have. I'll start with one by one. First one is the domestic demand. It is the amount of water required in the community for domestic usages. Second is the industrial demand. It is the amount of water required in the community for industrial usages. Third one is the institutional demand. It is the amount of water required in the community by the different institutes like schools, colleges, government hospitals, government buildings, hospitals, etc. Right? Then you have water for public use. It is the amount of water required in a community for road cleaning purposes, for watering the public gardens. Then you have fire demand. It is the amount of water required for firefighting if any fire outbreak happens in the community. And last one is thefts and losses. It is the amount of water lost due to leakages or the illegal connections in the water distribution system. So these are the different types of water demand based on the types of usages. Now talking about the quantity, how much quantity of demand are present. So domestic demand usually lies in the range of 135 to 225 LPCD. These values are important for PSC examinations, engineering service examinations and SSC JEE examination, also for ISRO and BARC. But in GATE examination, you may not expect these values. Okay, but still a good question can be framed, a good multiple select question can be framed using the values. So better you learn it, right? It is not a very difficult task. So first one is domestic demand lies in the range of 135 to 225 liters per capita per day, LPCD. Again, your industrial demand lies in the range of 50 to 450 LPCD. You see this, huge variation is present. Now, based on the amount of industry present in the community, this industrial demand will going to vary. If less industries are present, usually less industrial demand will be there. If more industries are present, usually more industrial demand will be there. That's why this much range is kept, 50 to 450 LPCD. Then you have institutional demand, which lies in the range of 20 to 50 LPCD. Then you have water for public use, which lies in the range of 10 to 20 LPCD. Then you have fire demand, which is either equal to 1 LPCD or it is calculated empirically. We will also going to see all the formulas by which we calculate the fire demand. Okay. Then you have thefts and losses, which comprises of 10 to 15% of the total demand of water. So when you add all these demand, the total demand of water lies in the range of 250 to 350 liters per capita per day. These values are important, okay? You can remember these values directly. It will give you certain idea that which demand is more. So you can see this domestic demand is always more, right? But for some of the cities, if huge industries are present, then in that case, you may get industrial demand more, okay? So these are the total demand of water and the different values of different types of demand, okay? Now, if you want to calculate the fire demand, it is calculated empirically. For different cities, different empirical formulas are used. So you need not to worry about which empirical formula to be used. If a question is asked in GATE examination, they will directly going to mention using which formula you need to calculate the fire demand. Okay, as simple as that. So the first formula for calculating fire demand is Government of India manual formula, which states that fire demand is equals to 100 root P. Here the fire demand is calculated in terms of volume, that is in kiloliters. The first formula for calculating fire demand is, as per Government of India manual formula, fire demand is equal to 100 root P, and here the fire demand is calculated in terms of volume, that is kiloliters, and P is the population of the community in thousands. Okay. The best way to remember this formula is to just practice one numerical using this formula. Now try this one. So as per Government of India manual formula, calculate the fire demand. Calculate the fire demand for the population of for the population of 2 lakh by Government of India manual formula. Chalo, try this one. The best way to remember the formula is to practice one numerical. So you need to find out the fire demand for a community of population 2 lakh using Government of India manual formula. So as per Government of India manual formula, as per Government of India manual formula, as per Government of India manual formula, as per Government of India manual, as per Government of India manual, fire demand is equal to 100 root P. Fire demand is equal to 100 root P. Now see this, the only catch here is this P. P is the population of the community in thousands. Okay. Here the population of the community is given to you as 2 lakh. So population is given to you as 2 lakh, right? Now see this, what is the value of P? Population is given to you as 2 lakh. Just see this. This is 20 and then you have 30. So this population is given to you as 2 lakh. P is the population of the community in thousands. So it is how much? This is 200,000. So here the value of P will be equal to 200. The value of P will be equal to 200 because P is the population of the community in thousands. So the value of P will be 200,000. So P will be 200. Okay. Substitute the value and get me the fire demand. Just substitute the value and please calculate the fire demand quickly. So, fire demand is equal to it is 100 root of 200. Just get me the answer for this. Please solve this and tell me the answer for this. Please tell me the answer for this. So this is 100 into root 200. So this will be 1414.21. And here the fire demand is calculated in terms of volume. Kiloliters is the volume, right? Especially whenever you are using any empirical formulae, these units are very important. So never miss the units, okay? You need to keep a check in which unit you need to enter the value and in which unit you will get the answer. Both the things are important. If you miss any part, definitely you will going to get the wrong answer, okay? So never miss that. Keep a check on which unit you need to substitute the value and in which unit you will get the answer. So you are getting the answer in kiloliters. This is the volume of water, okay? So as per Government of India manual formula, fire demand is equals to 100 root P in kiloliters and P is the population of the community in thousands, okay? This is the first empirical formula. The second empirical formula for calculating the fire demand is the Klings formula, which states that fire demand Q is equals to 3182 root P, and here the fire demand is calculated in terms of discharge. The unit of fire demand comes out as liter per minute, and again P is the population of the community in thousands. So chalo, what is the Klings formula? Klings formula for fire demand is equals to Q is equal to 3182 root P, and here the fire demand Q comes out in liters per minute, that is in form of discharge, and again P is the population of the community in thousands. So as per Klings formula, fire demand is equals to 3182 root P, where P is the population of the community in thousands, and the fire demand is calculated in terms of discharge, that is liters per minute. You can try this question. Calculate fire demand. Calculate fire demand of the community of population of the community of population 3,80,000 using Klings formula. Shall do this. The population of the community is given you as 3,80,000. You need to find out the fire demand using the Klings formula. So again, what is the Klings formula for fire demand? Klings formula for fire demand is Q is equals to 3182 root P, where P is the population of the community in thousands and Q is the discharge in liters per minute. So as per Klings formula, fire demand is equal to, as per Klings formula, fire demand is equal to Q is equal to 3182 root P, right? And P is the population of the community in thousands. Here you can see what is the value of P. P is 380. Okay, you have to just leave these 3 zeros and you have to just see this. So P is 380. If population is 3,80,000, the value of P will be 380. Substitute here. So this is 3182 under root of 380. And this will going to give you the fire demand in liters per minute. Just solve this. So this is under root 380 multiplied by 3182. So this is 62028 62028.6 liters per minute. Units are very important. Again, I am telling you, right? All these empirical formulas are totally dependent on the units. So you keep a check in which unit you should enter the answer and in which unit you are getting the answer. Here you are getting the fire demand in liters per minute. Here you got the fire demand in kiloliters, right? So these are important. So the second formula for calculating the fire demand is the Klings formula. According to that, fire demand Q is equals to 3182 root P, and where P is the population of the community in thousands. The third formula for calculating the fire demand is Freeman's formula. As per Freeman's formula, fire demand Q is equals to 1136 P by 10 plus 10. And again the fire demand is calculated in liters per minute, and P is the population of the community in thousands. So as per Freeman's formula, fire demand Q is equals to 1136 P by 10 plus 10. And here also P is the population of the community in thousands. Again, see this question. Calculate the fire demand. Calculate the fire demand using Freeman's formula. For a community of population of 548,693. For this population, you need to calculate the fire demand in using the Freeman's formula, right? So let's solve this. So as per Freeman's formula, fire demand is equal to, as per Freeman's formula, fire demand Q is equals to 1136 P by 10 plus 10. 1136 P by 10 plus 10, right? The population of the community given here is 5,48,693. So population is 5,48,693, right? Now the value of P will be simple. You divide this population by 1000, you will get the value of P. You simply divide this population by 1000 and you will get the value of P, and that will come out as 548.693. This is the value of P. P is the population of the community in thousands. So whatever population is given to you, divide that population by 1000, you will get the value of P. Once you have the value of P, substitute here to get the final answer. So Q is equals to 1136 548.693 divided by 10 plus 10. So after solving this, you can get the population, you can get the fire demand, and that will come out as, this is 54.8693 plus 10 into 1136. So this will be 73691.52. 73691.52, and again this will be in liters per minute. This fire demand will also be in liters per minute, okay? Just So this will be in liters per minute. So this is the next formula for calculating the fire demand. The third empirical relation for calculating the fire demand is the Freeman's formula. And as per Freeman's formula, fire demand Q is equals to 1136 P by 10 plus 10. That is one of the very important formula that we have for fire demand. Chalo, next. The next formula for fire demand is National Board of Fire Underwriters method. By National Board of Fire Underwriters method, if the population of the community is less than 2 lakh, then fire demand Q is equals to 4637 root P into 1 minus 0.01 root P. Here also the fire demand is calculated in liters per minute and P is again the population of the community in thousands. So the next empirical relation for fire demand is, as per National Board of Fire Underwriters method, if the population of the community is less than 2 lakh, then fire demand Q is equals to 4637 root P into 1 minus 0.01 root P. Here also the fire demand is calculated in liters per minute and P is the population of the community in thousands. If population of the community is more than 2 lakh, then according to National Board of Fire Underwriters method, this fire demand Q is equals to 5400 liters per minute for the first fire, and fire demand is equals to 9100 to 36400 liters per minute for the second fire. These are direct empirical values that can be used if the population is more than 2 lakh. But if the population is less than 2 lakh, then as per National Board of Fire Underwriters method, fire demand Q is equals to 4637 root P into 1 minus 0.01 root P. And here also the fire demand is calculated in liters per minute and P is the population of the community in thousands. Chalo, let's solve one question from this. Calculate the fire demand using National Board of Fire Underwriters method for the population of 1,50,000. Calculate the fire demand by National Board of Fire Underwriters method for the population of 1,50,000. For the population of 1,50,000. You need to find out the fire demand using National Board of Fire Underwriters method for the population of the community being 1,50,000. Step number 1. Whenever you have this National Board of Fire Underwriters method, first you check the population. If the population is less than 2 lakh, then only you apply the empirical formula. If it is more than 2 lakh, directly you will take the value. For first fire, it is 5400 liters per minute. For second fire, it is 9100 to 36400 liters per minute directly. So you can check the population. The population of the community is less than 2 lakh. So I will write down. Since population is less than 2 lakh, then as per National Board of Fire Underwriters method, fire demand Q is equals to 4637 root P into 1 minus 0.01 root P. Since the population is less than 2 lakh, then fire demand Q is equals to 4637 root P into 1 minus 0.01 root P. Here 1,50,000 is the population of the community. Then the value of P will be 150. Just divide this population by 1000, you will get the value of P. So P will be 150. P will be 1540 divided by 1000. That is how you calculate P. So this is 150, right? Substitute here. So Q is equals to 4637 root 150 into 1 minus 0.01 root 150. Calculate this, you will get the fire demand using National Board of Fire Underwriters method. So this is root 150 into 0.01, 1 minus answer into root 150 into 4637. So this is 49835. This is 49835.92. Here also the fire demand is calculated in liters per minute, right? So all the empirical formulas that we are seeing for calculating the fire demand, only one formula is there in which the fire demand is calculated in terms of volume. That is your Government of India manual formula. In rest, all the other formulas, the fire demand is calculated in terms of discharge. Okay, now coming to the last formula for calculating the fire demand, that is your Boston's formula. As per Boston's formula, fire demand Q is equals to 5663 root P. Again, the fire demand is calculated in liters per minute and P is the population of the community in 1000. So, as per Boston's formula, fire demand Q is equals to 5663 root P, where P is the population of the community in thousands and fire demand is calculated in liters per minute. So, let's see one question from this. Calculate the fire demand as per Boston's formula. For the population of 7894356 for the population of this, for the community, right? So as per Boston's formula, fire demand Q is equals to 5663 root P, and again the P is the population of the community in thousands, and here also the fire demand is calculated in liters per minute. So as per Boston's formula, the fire demand Q is equals to, as per Boston's formula, fire demand Q is equals to 5663 root P, where P is the population of the community in thousands. So for calculating P, you just write down the population, that is 7894356 divided by 1000. That will be the value of P. So the value of P will be, this is 7894.356. This is the value of P. Substitute here. So Q is equals to 5663 under root P, which is 7894.356. And this will going to give you the fire demand in liters per minute, right? Just solve this and get the value. So this is under root of 7894.356 multiplied by 5663. So this will be 503158. This will be 503158.62. And again it will be in liters per minute, right? So these are the 5 important empirical formulas for calculating the fire demand. Again, I'll repeat all these formulas. First one is, as per Government of India manual formula, fire demand is equal to 100 root P, where P is the population of the community in thousands and fire demand is calculated in kiloliters. Second one is Klings formula. According to Klings formula, fire demand Q is equals to 3182 root P, where P is the population of the community in thousands and fire demand is calculated in liters per minute. Third one is the Freeman's formula. As per the Freeman's formula, fire demand Q is equals to 1136 root P, where P is, as per Freeman's formula, fire demand Q is equals to 1136 P by 10 plus 10, and here also the P is the population of the community in thousands, and fire demand is calculated in liters per minute. Next one is, as per National Board of Fire Underwriters method, if the population of the community is less than 2 lakh, then fire demand Q is equals to 4637 root P into 1 minus 0.01 root P, where P is again the population of the community in thousands, and here also the fire demand is calculated in liters per minute. If population is more than 2 lakh, then for first fire it is 5400 liters per minute, and for second fire it is in the range of 9100 to 36400 liters per minute again. Last one is, as per Boston's formula, the fire demand Q is equals to 5663 root P in liters per minute, right? So these are the 4-5 important empirical relation of fire demand. Usually, if any question comes from the fire demand, they will actually going to mention which method to be used. So don't take any method, okay? Please read the question properly in order to identify the method. Okay, chalo, moving ahead. Next one is, there are different factors which affects the water demand. The first factor which affects the water demand is the type of the sewerage system. My dear student, if the sewerage system is not efficient at your house, then you will require more water for washroom. Okay, you will require more water for like cleaning purposes. So if your sewerage system is not efficient, then it will directly going to affect the domestic demand. So type of sewerage system, it affects the domestic demand. It affects the domestic demand. It affects the domestic demand. Affects the domestic demand. Please remember which demand is getting affected, right? You may expect a multiple select question from this. So type of sewerage system, if your sewerage system is not proper, it will directly going to affect the domestic demand because you may require more water in your toilets. Next one is the extent of industrialization. So next factor which affects the water demand is the extent of industrialization. This is very simple to understand. If the number of industries are more in the community, then the water required for industrial use will be more. Therefore, the industrial demand will be more. So extent of industrialization, it affects the industrial demand. It affects the industrial demand. It affects the industrial demand of water. It affects the industrial demand, right? So extent of industrialization means more industries are present, means more water will be required for industrial purpose. Next one is the size of the city. Now, my dear student, this is a bit tricky, right? So if the size of the city is more, then length of the road network will be more. Then the size of the gardens will be more, okay? Therefore, water required for road cleaning purposes and watering of these public gardens will be more. So size of the city affects water for public use. More the size of the city, more will be the water for public use, required for public use. So size of the city, it affects water for public use. Affects water for public use. It affects water for public use. Next, you have type of gentry. Now, as the living standards of the people is increasing, hence their domestic water requirement is also increasing. It is directly related. If your standard of living is more, right, you may have more number of washrooms, you may have more people sitting together and having food. And that is how your domestic demand also increases. You can enjoy the jacuzzi, right? In that, huge amount of water is required. So if your living standards is increasing, then the water used for domestic purpose also increases. So type of gentry, it directly affects the domestic demand of water. It directly affects the domestic demand. It directly affects the domestic demand, right? It directly affects the domestic demand. So 4 factors: type of sewerage system affects the domestic demand, then extent of industrialization, again it affects the industrial demand, then you have the size of the city which affects the water for public use, then you have type of gentry which affects again the domestic demand. The next factor is the climatic condition. This is very simple. If the climatic conditions are hot, again, more water will be required for bathing purposes, for cleaning purposes. More water will be required in in coolers, right? Then you have different types of like cooling system. Sometimes they require water. So if your climatic conditions are hot, again your domestic demand will be affected. So climatic conditions affects the domestic demand. It affects the domestic demand. Affects the domestic demand. It affects the domestic demand, right? Now then you have cost of water and you have quality of water. Now my dear students, if you're feeling thirsty, right, and you actually require 1 glass of water to drink, but that water is like filthy water. It is not such a good quality water. So you will not going to drink that water for sure, right? That is what we mean. But still, that just to get out of that thirst, you require 1 glass of water. So if your quality of water is poor, your thirst is not satisfied. Thirst is still there. Means demand of water is still there, but still you are not consuming that water. So if quality of water and cost of water are there, are the factors. If cost of water is more, then consumption of water is less. Demand of water is same only. Similarly, if quality of water is poor, then again the demand is there. Demand is same, but again the consumption is affected. Consumption is reduced. So if cost of water is more, again it affects the consumption of water. And if quality of water is poor, again it will going to affect the consumption of water. So cost of water and quality of water, since they are affecting the consumption of water, that's why we say that they are indirectly affecting the water demand. So cost of water and quality of water indirectly affects the water demand. They indirectly affects the water demand. They indirectly affects the water demand, right? They indirectly affects the water demand because these two, cost of water and quality of water, they affect the consumption of water. They affect the consumption of water. They affect the consumption of water, right? They affect the consumption of water. Last one is pressure in the water distribution system. So if pressure in the water distribution system is more, then in that case leakages will be more, losses will be more. So pressure in the distribution system, it affects the losses. It affects the losses. It affects the losses, right? It affects the losses. So these are the different factors and we have written which factor is affecting the which demand. So these factors are important based on the multiple select question, right? So you can just remember all these factors and the different demand they are affecting, okay? So these are the thing, okay? Chalo, moving ahead. So this is for all. This is for today right now, okay? I hope you have understood some of the basic of how to start environmental engineering. In today's class, we have seen some important formulas and important factors that affects the water demand and formulas which are used to calculate the fire demand. So a chance of numerical we have discussed today. You should practice this, you should understand this and you may get certain other questions, right? Okay, so this is all for now. Again, I will going to repeat myself. Our Telegram group link is there in the description box. Please join the Telegram group to enjoy the daily quizzes, to get the job notification updates, to get the updates on the counseling sessions. So all these updates are there. We at IMS GATE Academy, we provide you with 4 different types of courses where we provide you 800 hours of live teaching with interaction and doubt solving. We give you theory books and exercise book which contains 4000 plus practice questions well versed in level 1, level 2 and level 3. We give you the GATE question bank containing 34 years of GATE questions with detailed solution, with alternate solution, with video solution, with key points and with chapter overview. We provide you with 12 personalized one-to-one mentoring sessions to keep you oriented, motivated and well planned for your entire GATE preparation journey. We provide you with India's largest test series containing 130 plus tests, which starts from the chapter test, subject test, multiple subject test, advanced subject test, full length mock test with the video solutions. If you want to speak to our counselor, you can just dial these two numbers, and even if you feel like speaking to our mentors, again you can ask, they can arrange one meeting for you. So this is all. Myself Prateek Mishra signing off for today. Tomorrow I'll be there at the same channel, probably at the same time, with the brand new topic of the next session of Foundation series of Environmental Engineering. Thank you so much for listening patiently. Have a very great day ahead. Thank you so much.